This is Math 107, practice test number 1, problem number 9. We're supposed to test the validity of this argument. And remember, when we test the validity of our argument, one way we can do it is make a truth table. If everything ends up being true with the final argument, then the argument is valid. So if I pick you up, I'll call that P. I will get a hernia, I'll call that Q. If I get a hernia, I already called that Q. Then I can't play we. I'm going to use this as a negation. I can play we, I'm going to call that R. So I can't play we would be not R. I didn't, negation, pick you up, so that would be not P. So the structure of this argument is P implies Q. If I pick you up, then I will get a hernia. Q implies not R. If I get a hernia, then I can't play we. And then just a statement, I can play we. Therefore, I didn't pick you up, not P. So the argument is really each of these pieces, P implies Q in the premise, and Q implies not R, and R. All these things, all these ands, have to imply not P. So let's build this truth table for it. And notice that I have three statements, P, Q, and R, in here. So it's going to be a little bigger, a little larger of a truth table than we've dealt with before, but we can do it. I have three possibilities. Each of them can be true or false. Each of them have two possibilities. So 2 to the third, 2, 4, 8. I'm going to have 8 entries. And the way I'm going to organize it is I'm going to go by 4s for my first one. So 4 trues, 4 falses. This is just a nice systematic way to get all the possibilities. 4 go by 2s here. So 2 trues, 2 falses, 2 trues, 2 falses. Again, make your trues and falses easy to read. More my problem than yours. And then I'll go by 1s. True, false, alternate by 1. True, false, true, false, true, false. So now I have all 8 possibilities, every possible true, false combination for P, Q, and R. So now I'm going to just start to build this argument. P implies Q. Remember, an implication is only false when the premise is true, the conclusion is false. So true, true is true. True, true is true. True, false, false here, false here. And then if the premise is false, doesn't matter. The argument's still true. It hasn't been proven false. So true, 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 true. Q and not R. Let me throw in a little not R here. Negate R. Just going to switch all those signs. So false, true, negation just switches the truth value. So my next piece is going to be Q and not R. So Q implies not R. So Q implies not R. So true to false, that's false. True to true is true. False to false is true. Remember, if my premise is false, my implication is still true. True to false, that's false. True to true is true. False to false, false to true, those will both be true. So I have this and this. I already know R. So now I have this big combination of this and this and this. I'm just going to call it and because I'm feeling lazy to rewrite it. But basically this is the and for all 3 of these. All 3 of these ones put together. And so what that means is all 3 of them have to be true in order for this to be true. And notice what I'm comparing here is P implies not R, P implies Q and R. So if all 3 of them are true, I'm in good shape. If not, it's going to be false. So 1 false makes it false, 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 makes it false. True, true, true. This is the one that's true, makes it false. So everything's false except true. I'm sorry, except that one case is true. So now, since that's that part, what I want to know is, when does this imply that? And so I'm going to need a not P column to compare with. Not P. It's just the negation of all these. So this would be false, 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 true, 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 true. And now my last piece is, how does this, which is right here, imply that, which is right here? And notice this is actually pretty straightforward. If my premise is false, my implication is true. So all these are true. And then the only one I really need to worry about is this. True implies true. That's true. Yeah, they're all true. 3, 4, 5, 6, 7, 8. So this is called a tautology. It's always true. So this is a valid argument.